Hi everyone, my name is Brian, and today I would like to talk about short-term variability of carbon chemistry in two contrasting seagrass meadows at Dongsha Island, implications for pH buffering and CO2 sequestration. First, let me talk about net zero. Net zero is an achievement we would like to get in 2050 to balancing the greenhouse gases produced with the amount we removed from the atmosphere. So we are focusing on how to remove CO2, and the easiest way is the photosynthesis. Let's take a look at the seagrass meadows. Seagrass meadows only occupy 0.1% of the world's ocean, but they may contribute almost 10% burial of organic carbon in the ocean. Has anyone found something wrong about this one? Okay, here comes our research. We selected two different spots for our experiment. The North Shore is an open environment with energetic water exchange and short water residence time. In contrast, the inner lagoon is semi-enclosed and sheltered. It has a long seawater residence time. Although the two locations are not far apart, they only have distance of 500 meters, but they have the hydrodynamic features are very different. We use the high frequency. We track these two places using high frequency sensors to capture their data, including pH, CTD, DO, dissolved oxygen, DIC, dissolved inorganic carbon, and PCO2, partial pressure of carbon dioxide. And the most important one is TA, total alkalinity. So what is TA? TA refers to the ability that seawater resists the acidification of the ocean. Increasing TA leads to increasing pH and the decrease of partial pressure of carbon dioxide. And about the seagrass meadows, when the photosynthesis works, it makes TA higher. Let's look at the data we get. Let's look at the data we get. As the figure shows, the inner lagoon had the more higher TA than the North Shore, and the diverge in total alkalinity significance shows the inner lagoon has the lower partial pressure of carbon dioxide that makes there a better carbon capture machine. But why does the inner lagoon get higher total alkalinity? These two places have the almost same species of seagrass. We want to find out where these gaps come from. So we need an index called apparent oxygen utilization, which is AOU, to track the extent of photosynthesis and respiration, because they all related to O2. And when the photosynthesis greater than respiration, it makes TA higher. And overall chemical reactions. Seagrass meadows photosynthesis makes TA higher. And as the figure shows, the North Shore station's data all agree that PR could be the dominant process controlling the TA in the seagrass meadows, like this green line here. However, the relationship between TA and AOU at the inner lagoon station mismatches, like the green line here. It means it means mismatches from the theoretical result caused by PR, like the red line here. So there's a different slope between two slopes. And this mismatch shows that some processes other than the PR may significantly enhance the value in TA at the inner lagoon. So that's why we need another index, which is DIC, dissolved in organic carbon, to find the last missing part. This index can help us track these three possible answers: CaCO3 dissolution and aerobic respiration and sulfate reduction. And I'll introduce them one by one. Okay, first let's look at the CaCO3 dissolution. As the chemical formula shows, this reaction consumes H ion that make the pH higher, and the TA also gets high. pH gets higher and the TA also gets higher. And the second one is aerobic respiration. Aerobic respiration produce CO2 that makes seawater's PCO2 decrease. But this won't affect the final TA. So the aerobic respiration is not our answer. The third one is the sulfate reduction. This reaction produce basic ions like this one. And it increased TA because TA will be affected by all basic ions. So this could be the final answer because it makes TA higher. And we found the most effective factor is the inner lagoon's third one. In the inner lagoon is the third one, sulfate reduction. Compared to the open North Shore, the inner lagoon has very slow water flow. It leads to the deposition of the fine organic debris and limited oxygen diffusion. Aerobic respiration quickly consumes oxygen in the sediment pore water. And once oxygen is gone, microorganism must switch to anaerobic mode to decompose organic matter. It's anaerobic. Okay. In seawater, the concentration of sulfate is much higher than other oxidants. Therefore, the sulfate reduction becomes the dominant factor, releasing massive amount of total alkalinity, which is TA, into the lagoon. As sulfate reduction releases TA, this reaction could also explain why the inner lagoon has higher TA than the North Shore, because sulfate reduction right here. And because the limited water exchange, this sedimentary TA accumulates, boosting the pH buffering capacity of the lagoon. This research demonstrates the crucial role of hydrodynamic mechanism in regulating biogeochemical process and carbon sequestration capacity in seagrass meadows. In conclusion, hydrodynamic is the key. In sheltered area like the inner lagoon, long residence area allow TA to accumulate, enhancing the buffering effect against ocean acidification and build a stronger CO2 sink. This means specific coastal environment can be even more powerful in carbon sequestration than we previously realized. Thank you for your attention.
I want to ask page 10. We can see that in North Shore the salinity is concentrated, but why is IL have very different salinity in the same area?
I think it's because the water exchange in the North Shore is very frequency, so it could be balanced, like mixed. But in inner lagoon, because the water don't flow, the salinity won't mix. It will be separated by different parts.
How does a high TA value help protect the seagrass system from the ocean acidification?
Please repeat your question again, please.
How does the high TA value to help the seagrass system to from the ocean acidification? How does it works?
Oh, I think higher TA means more CO2 can dissolve into the ocean because PCO2 decrease, and it means the PCO2 in the atmosphere will be higher than the ocean. Then more CO2 will sink into the ocean, and the photosynthesis could be boosted.
Can you explain again what is the purpose of this study?
Oh, it's trying to find why the inner lagoon had the unusual high TA. It could help us to assist the carbon capture.
All right. So you should understand your weakness, right? You were looking at your phone, and sometimes there were breaks during your sentence. That means you were not very familiar with your line. So next time, please improve the fluency of your talk by practicing another 50 times, maybe. And then try not to look at your phone in your talk too. And you also need to look at them. For the audience, look at the audience. Okay. And here, where is the, okay, this is annoying. And here, this is, okay, you try to talk about the CO2 capture, and you say something about photosynthesis. These are all easy to understand. However, I think you can recall the question of Bella, because in this presentation, at the end, you were focusing on the discussion of TA. So maybe instead of this a little bit like a common sense, maybe you can spend some time explain why we should care about TA. Okay, so how does that affect the carbon sequestration? And then you can recall the question from Sean that he was asking you the purpose because there was no purpose slide. You need a slide, dedicated slide for the purpose of the study with a sentence clearly stating what is the purpose. Okay, and then here you started to show the study area. This is okay. However, I feel that I think most people, they know Dongsha as here, not here. But the study was all about here. So I think this image should be reused again and again whenever you talk about your result. I will tell you later where. And here you started to talk about this important carbonate parameter, but I suggest that maybe you can bring them forward, especially when you want to introduce TA. why TA is important. And furthermore, since you want to talk about carbonic chemistry, then I should really be picky. Like this P and this P should not be capitalized. Okay. Then here, this is something I really think maybe you can even use it in your introduction. Since you want to talk about seagrass and you want to talk about carbonic chemistry, you just use it. Okay. Then you started to talk about your result. And in your result, first of all, please reuse the image of showing the inner lagoon and NS. And then when you talk about here, this result, you did not introduce it. Salinity and total alkalinity, you need to introduce it and use the map of the inner lagoon to introduce this and this. And then you start to have this AOU. What was missing? Because here you say a lot. At the end, I was a little bit confused. I think all you need to say is, what does it mean by having higher AOU and lower AOU? And because AOU is not that easy to comprehend, maybe you can repeat that again here. This direction means the what, and this direction means what. Especially AOU has negative value. Then you need to tell us, what does that mean? Positive, negative. And another thing that makes things more complicated is you have NTA, not TA. Okay, maybe you would like to use this graph to explain NTA. You know, N means normalized to salinity. And you probably need to briefly explain why we use NTA. Okay. And again, you need to use the photo of the lagoon to show what is the red dot, what is the red, and what is this different symbol, where the samples are from. Okay, then you started to talk about these three possibilities, and then here, my feeling, I feel that it is good that you have these kind of arrows to tell us the direction of change, but I feel that when you talk about this, you can briefly guide through this equation, and then tell us, because you have, for example, like you have bicarbonate as a product, so bicarbonate will increase when this happens. You need this kind of guidance, instead of just saying, okay, carbonate dissolution will cause this, this, and this. Go through the equation shortly, and the same here, and the same here. Okay, and then sulfate reduction is probably very not familiar to most of them. And therefore, I suggest that maybe you can tell us a little bit more about sulfate reduction. A little bit more. Like a sulfate is the most abundant oxidant in the ocean, something like that. Okay, and then you say this one should be more effective, and then you start to explain why this is the case because of the flow field, etc. And here, please show the image of the lagoon again. And at the end, in your conclusion, please, because this is a little bit too general, please shortly repeat the main finding of the study before you draw this very general conclusion. You need to repeat the main finding. Okay, I hope to see your improvement next time. Thank you.